Hello friends and followers of my channel, welcome to today's tutorial. Just on this video I try to show you how can we prepare data for the purpose of data analysis or climate change analysis through a trend analysis method, since climate change is a global issue and currently many researchers are researching on this global issue. So for this purpose, basically there are different types of statistical test methods of climate change analysis, maybe coefficient of variation, standard anomaly index, and different trend analysis method such as parametric, non-parametric, and one recent method which is innovative trend analysis method. So for any of these statistical test method, just data where a key input or a key parameter that governs just the results that will generate. Not only the raw data, also preparing data which is suitable for the methods was just a key input or a key task. So due to that reason, just on this video what I will show you was how can we prepare data especially for trend analysis method. Maybe if we are using just a tool which is man-candle test tool or sunslope estimator. So for this tool, how can we prepare data will be shown in this video. So for that purpose, basically here I have just 30-year data starting from 1991 to 2020. First, let me give here just the months are given in number format. So let me give names for each months. It starts with January, which means just one designates for the month January, and here we have February for month 2. Then just here up to December. Then the data preparation depends on just seasonal variation, which is found in Ethiopia. So it says climate seasons of Ethiopia include basically 4 seasons. These seasons are, the first one is summer. Also it can include basically 3 rainy seasons, starts from June to August, and the second season was autumn, and also it can cover basically 3 months, September to November, and the third one is winter, which is basically cover the most driest seasons of the country, which are December to February, and the last season was just spring, which is or it can include March, April, and May. So based on this seasonal variation, just we will designate just 13 for summer, 14 for winter, just 15 for here, sorry, for autumn we will designate 14, 15 for winter, and for spring let's give number of 16, and here 17 just to show the annual variations in the data. So here it says for the case of September, just it says it can cover the months, rainy months, starts from June to just August. So this is equals to just the summation of the rainy seasons or just the summer seasons. Then for the case of just autumn, it says here it can cover just basically September to November. So here this is equals to just September, sorry, sun, September to November. Then just for the case of winter is equals to just it says December to February. It says December to February, so let us sum the value is equals to value for December plus just value for January plus value for February. Yeah, value for February. Then for the case of spring season, it can cover just March to May, so is equals to some values starts from March to May. Then here 17 stands for just to show the annual variation, so it can cover also the whole season. So some values for all months, just 1 up to 12 or January to December. Now just drag for all the years, just from 91 to 2020. Then here just after generating the result, what we have to remember was just the designation, because here 13 stands for summer, 14 stands for autumn, and 15 stands for winter, 16 stands for spring, and 17 stands for just for the annual variation. This is just for my case. You may consider maybe just 13 for autumn, only just the difference was considering months that are designated for the seasons for the case of autumn. Then after let me remove just the name of the month, and here I will add just one row. So here what I will make was just here I can give a number of year, which is 30, because number of year 91 to 2020 being just 30 in number. So here I can give 30, and here 17, that's number of all the seasons including each months. Here it shows 1 up to 70. Then here I will write 17, and here also let me give a name for my case. Let me give here buoy just in bracket 1991, sorry, 91 to just underscore 2020. Then after I will save in CV table format. So the man-candle test estimator, man-candle test and sun slope estimator tool can accept only values in the form of text format, which is in comma delimited. So here I will write or I will save as the preparation in text format. Let me save this in desktop for my case. Here let me find text tab delimited. Here there is a text tab delimited, so I will make or I will click on just text tab delimited, then save. Yes, let me check the saved file here. So this is just the data which is suitable for man-candle and sun slope estimator tools. So on the next video I will show you how can we use just the man candle test and sun slope estimator based on this prepared data. Thank you for watching me. Please subscribe my channel and share my tutorials and my channel to your friends. Thank you.